here in Boston, where I'm based. It's well, it promises to be quite a nice sunny day. It's early in the morning here. We have, I think, a lot of content we want to get through, so I'll try and keep the intro kind of as short and sweet as possible, whilst leaving and then enough time for, as Alex said, the Q&A at the end. So, a bit about me. Well, I think it's fair to say I've been around this, being around the particular, DevOps, Biz, QA cycle a few times. My background is in high-performance software development, but also run reasonably large, scalable, kind of operational facilities. And I've worked on the business, on the requirement side. I've been part of a QA team, so yeah, as I said, I've been around this block a few times. Now, obviously, as Alex said, my role is as VP of Product Management for XebiaLabs. But when I'm not talking to Gartner or people like that, I try to keep my skills sharp by contributing a whole bunch of open source projects, and it's always good to get your hands dirty in that sense. And yes, if you're going to go to some conferences or meetups or so, you might well run into me there. I've spoken at DevOps Days. I'll probably be doing that again soon. So hopefully see some of you around. That's a more formal photo. If you don't like me smiling like that, then we can have the professional photo as well. Just a little bit about XebiaLabs. Who are we actually? Well, we're a Boston-based, that's why I'm sitting right now, provider of delivery automation software. So pretty much from the point where you've actually written all the fantastic code and you have your great feature all coded out, anything that needs to happen from the point of that point on to when it's actually live and your customers are using it. So whether it's rolling it out a bunch of target systems or maintaining some kind of test or quality profile throughout your pipeline, or orchestrating your pipeline itself, spinning up environments to get your application tested. That's pretty much the kind of sphere where we do business, if you like, where we help customers. And of course, what's our goal? Well, we want to help you be able to get your great code out to your customers faster, better, cheaper. I guess that's the kind of standard goal that I should hope any automation company has. As Alex said, I'll just recap on a little bit of housekeeping. So the webinar is being recorded. There'll be a question and answer tab in the GoToWebinar control panel. I know the screenshot's just a little bit out of date, but yes, if you do have any questions either as we go along or afterwards, please feel free to put them in the chat. Depending on the time, we may or may not get round to answering all of them. Of course, we'll follow up any questions that we don't get round to answering here, and please feel free to contact me or us afterwards if you come up with some really interesting question after the fact and you'd like to enter into a bit of a discussion. I'll post my contact details at the end of the webinar. Okay, so what's the agenda for today? Yeah, fair to say, given the kind of 30 to 45 minutes we have, very, very tightly packed agenda. So what are we going to be talking about? I'm going to give a very, very brief DevOps intro recap. I'm kind of expecting that that's reasonably familiar to most of the people who've joined. I'll talk a little bit about what a DevOps tool actually is, since we're going to talk about the DevOps tooling landscape. Now I'm going to pick 5 of the many different possible tool categories specifically related to delivering applications, and I'll talk a little bit about why, and then I'd like to talk a little bit about how you can take this kind of abstract information, if you like, and make it practical and relevant for your particular scenario, and try to figure out, well, what you need at this particular moment in time. And that's when we hopefully wrap up and have some time for a bit of a Q&A. Just in terms of expectation management, pretty much all of the topics, certainly the 5 tool categories, are easily worth a whole Coursera course in their own right. So we're not going to be able to cover everything here for sure. I think if we can get to the point where we have a shared basic understanding, and you think you know where to take the discussion from here, then I think we're doing really well. Okay, so let me start out then and give a very brief kind of lightning DevOps recap. Where does DevOps come from? Well, the famous original first session proposal that Patrick Dubois put up when he called it Agile Ops, actually, not DevOps at the time, was really about extending Agile principles to operations. If you have some familiarity with Agile development processes, then you know that there's the magic Scrum board or Kanban board or whatever, and you have all these wonderful stickies on there, and there was this weird experience for him where the life just kind of ended, the development team finished. But of course, the reality is that that's only when a service starts to get interesting, because you then have to get it rolled out into production, get your customers using it, etc. And really applying a lot of principles from that same kind of methodology. Can we work iteratively? Can we work smarter, more integrated way, more shared knowledge? Can we basically make this board bigger and start to include the people who actually end up running our applications to make sure that they're involved all the time as well? And that, well, it's not actually breaking down the well. That's kind of interesting little typo there. We're not really breaking down any walls, but we're certainly trying to break down walls here between development and operations. And well, that's obviously an organizational, it's a cultural, and of course it's also a technical challenge to some extent, but we're basically trying to get away from the sort of standard model where developers write a whole bunch of stuff and then they throw a big bundle with a manual over the wall, and then a bunch of people have to kind of make it run without really understanding what it is or having a huge amount of influence on how it can be developed, how it could be improved, and so on. And so a lot of this, if you read some of the case studies of successful DevOps organizations, it's not just about implementing a particular tool. It's really about having a shared culture, a kind of information flow across development and operations. So everybody, first of all, understands what they're working on, what the kind of services that they're trying to deliver. And they're also motivated to work together to achieve this goal because they have a shared kind of incentive structure. You no longer have the, well, developers are motivated to change stuff, operations people are motivated to keep stuff running. Instead, they should all be motivated together to deliver the best possible service to your customers, which of course involves a trade-off between amount of change and stability. And I think another important thing, it's now DevOps, and frankly, I personally like to spell it with a lowercase o. I know that the market trends have gone away from me there a little bit, but really it's about getting development and operations working together, so there really shouldn't be the separation between them that capital letter implies there. But there's, of course, also QA is involved here. The business should be involved here. It's everybody who's involved in making this service happen. So if you see kind of proposals about creating a DevOps center of competence or a specialist DevOps team or something like that, that's almost the antithesis of what DevOps really is about. There's a very interesting blog, I think John Willis wrote it, I can't remember who did, where he vents some steam about this idea. The last thing you want to do in order to try to create more shared understanding is to create another specialist unit that's external and that comes in and does stuff and doesn't really tell you much about what they're doing. And it's also, as I said, it's not really about, oh, I've installed, whatever the current flavor of the month tool happens to be, so now I'm a DevOps organization. Of course, tooling is related to DevOps. That's exactly what we're here to talk about. But the goals that we're looking at here go way beyond introducing a particular set of tooling. Patrick Dubois wrote an interesting kind of maturity model where he talks about 4 or 5 different maturity levels for DevOps, and actually having tooling in place is kind of maturity level 1 or 2. It's really just the starting point. So didn't I just say, yes, well, it's not about running a particular set of tools. That's true. So why are we now talking about what is a DevOps tool? Well, I've kind of said this a little bit already. Tooling is not the goal of DevOps, but if you look at what DevOps tries to achieve, tooling is certainly a major component in delivering some of these goals. And of course, it depends what exactly your organization is doing right now. But for instance, if you want to empower your team to have more flexibility and not be dependent on 1 or 2 specialists in order to get a new environment ready, then tooling is a great way of enabling that specific goal. And then, yes, then you will need some DevOps tooling to make that happen. So tooling is not a goal, but it's a powerful means. And I think that's one of the reasons why, of course, we're seeing such interest and adoption around DevOps tooling, as well as the fact, to be perfectly honest, that tooling is always much easier to introduce than any specific cultural or process change, which always requires much more buy-in and needs to be more carefully managed in an organization. So tooling is also a relatively straightforward, known way to start now, because it's becoming a hot topic. If you Google like DevOps tool, pretty much any tool out there that tries to do anything in either the development, delivery, or operation space is labeling itself as a DevOps tool. So, from this sort of communication and collaboration stuff, you've got monitoring, alerting, system testing, disruption, the cool tools like Chaos Monkey, the list goes on and on and on. We're not going to be able to cover all this today, obviously, but there's a huge spectrum of different tools that you can use as part of a DevOps implementation, obviously. And more than happy, and I've got experience with all these categories, so more than happy if you're interested in any specific one to have a more detailed conversation about them. As I said, the vendor bandwagon isn't making things easier here because pretty much anybody who's putting a tool out in any of these spaces is now calling it a DevOps tool. What we're going to do today, we're going to talk about some of these categories. So it's very confusing, and it's certainly confusing for me, and I've been looking at this space for a very long time now, trying to gain some kind of feeling for what these tools do. And then, I mean, I listed the categorization just there. The challenge is that very few tools aren't easily able to be pigeonholed in one of these particular categories. Obviously, they all try to expand the range of what they can do. Certainly, the companies market the tools as being able to do a whole lot more than they're typically really good at. So, trying to figure out where all these combinations of tools and new tools fit can be very difficult. And if you're confused, then I fully understand that. Now, I've been trying to set this up for a couple of organizations as well. I know it's not easy to try to make a sensible choice and to have a feel that we have enough tools to cover our needs and we're not missing something important, and we're also not getting too many tools in-house where we can have one that does most of these things pretty well. What am I going to focus on here? Well, I'll focus on the categories of tooling related to application and service delivery. And why am I going to do that? Well, for two reasons. One, of course, that's our specialist area of expertise, so we can talk best about those particular products and tools. And yeah, I can give you a very, hopefully, good and practical advice on those. But also, if you look at what analysts are saying, and if you now, as DevOps is becoming more of a kind of CIO level discussion, you'll see that a lot of the kind of justification for doing DevOps comes from the idea that DevOps allows you through practices like continuous delivery, which is falling under the DevOps umbrella a little bit, to accelerate the time to market of your services and be able to get your code out to customers faster. I don't think that's the only goal of DevOps, far from it, but it's certainly one that has a very tangible and natural business benefit and that appeals, if you like, to the kind of CIO level. So I can see why the discussion is going in that way a little bit. There's actually some very interesting metrics about this. We've just done a survey of the state of software delivery, and I don't think it's released quite yet, but if you're interested in that, either me or keep a lookout on our website. We'll be going into that kind of stuff in much more detail, what people are actually planning for this year. Okay, so of the various categories that I listed up there, these are the 5 that I'm going to focus on here. And as I said, we can certainly talk about the others in more detail if you're interested in that particular thing. I'm going to talk about task execution, call it job running, or whatever, but I'll define them in a second. Cloud and container management, they're a little bit separate, the two, but I'll try to explain why I've merged them here. System provisioning and configuration, application build, integration, deployment, and pipeline operation. Well, we'll actually split the discussion of application integration and deployment into 2 because they're really generally served by 2 different types of tools or 2 different families of tools, one of which is much more established than the other. But I think from a functional perspective, they really belong in one category. And then what I'm going to do at the end of this discussion, I'm going to try and place them into this kind of, if you like, well, 2-dimensional graph. So what we're looking at here is a space on the horizontal axis. We're looking at the kind of time or close proximity to the customer dimension. Build is, pretty much the development part of your life cycle, and then at some point your application or your service goes live, and then it's in production and it's running with your customers. And then in the horizontal axis, what we're looking at is the kind of, depth of your stack. So it's from the OS level up all the way to where the application is running at the top. And I'll try and place the various tools or the tool categories into this particular diagram. And then hopefully that will give us a sense of where they fit and where we see them as being effectively used. Okay, so let's start out with task execution tools. task runners, job runners. You can call them whatever you like. So what do these tools do? Well, the idea of these tools, a popular example will be something like Rundeck, if you've heard of that. They basically allow you to run arbitrary commands or script on a number of target systems. And they might just not be, you can do that as a kind of one-off. You can say, I want to run like echo hello on 100 machines, but you might also be able to set it up as a task that can be run on a regular basis and once a day on a certain condition and so on. So what are these tools really good at? I mean, they're great kind of Swiss Army knives to have. It's very easy rather than logging into 100 machines yourself and trying to like repeat a command all over the place. They're great for cleanup, maintenance, simple management activity, clearing a cache, bouncing a server, killing a process, emptying the temp directory, whatever you can think of. It's kind of like what you would do with cron on one machine, but then massively across a whole bunch of different machines, and typically with a nicer sort of UI than cron provides to allow you to see which tasks exist and which ones are targeted at which machines and so on. The interesting thing here is that a task execution tool, of course, pretty much everything that we're going to be talking about, anything to do with remote automation, is just another task. So all the other tools in this space that we're going to discuss have to have this kind of basic functionality within them. They all have some kind of task execution framework because that's really everything they do. What are these tools not so good at if you're going to use them as a sort of vanilla thing? Well, if you have a process that is not simply a matter of logging into 100 machines in some arbitrary order and clearing a temp directory, if you have a sequence of tasks that are actually dependent on each other, you need to log into the server 1 first, and then you need to go to server 2 and do something else, and then server 3, and then back to server 1, and so on. Then these tools can start to be a little bit more complicated. Some of them support this model, but it starts to get more complex, the things you have to set up here. Hybrid environments are something that can be challenging, again, depending a little bit on the tool. Pretty much all of them have excellent support for Unix environments, which I guess makes sense because that's the standard kind of server platform, certainly in sort of large IT shops. But yeah, there's plenty of people, certainly people we see, who have either full Windows environments or a hybrid setup of Windows and Unix environments, and the ability to be able to run in the same kind of manner tasks on both Windows and Unix is important. Windows support varies quite widely between these types of tools. And as I said, most of them give you a platform to run an arbitrary command, which is great, but you do have to specify that command yourself. And if it starts to get more complicated, you're basically creating a script and then having this tool execute it for you. If you want to have some support, if you want to say, well, I don't know, I'm installing, I don't know, Apache or something like that, and there's some steps that you want to do, there's not that much out-of-the-box contents tools generally provide to do that for you. You're creating the script and then you're running it. So you get the full freedom of doing this, but also the effort, obviously. So the next category I'd like to talk about, which is well, kind of low-level category here, is cloud and container management. And well, what do I mean by these? They're a little different. They serve the same kind of fundamental purpose of giving you a kind of running infrastructure middleware sort of platform, but they do it in a slightly different way. Cloud management, I mean, essentially all the APIs that you have that you can talk to for something like an OpenStack, an Amazon, AWS, EC2, for example. Things that allow you to directly, vCloud if you're using VMware or something like that, things that allow you to directly say, look, I want you to spin up a new virtual machine, I want you to create a virtual network, anything that these cloud platforms support. Basically, you can have a kind of category of tools that try to provide, instead of explicitly saying, make me one of these machines, make me one of those machines, and then one of these, and make a network and connect all of them, why can't I define that as really have the system take care of making all the underlying resources for me? So here you can space, OpsWorks, VMware App Director, a bunch of things like that. So some open source, some commercials, right scale if you're in the EC2 space. But you also, especially the new kid, the hot kid on the block right now in this area is Docker, which is, of course, well, limited to, if you like, one container, a Linux container. The LXC family of things are also in this area. So what do these things do? What are they good at? well, they give you a way of defining an on-demand environment that you need, whether that's a test environment, a QA environment, production. If you were using the low-level APIs directly, of course, you can also do more fine-grained things, like you can scale your environment by adding new servers and hooking them into the existing load balancer or whatever. But that's really, they provide a very solid foundation for all the rest of your kind of testing or delivery activity. What's very convenient if you can define this environment in such a way that you can both instantiate a small version of it on the developer's machine so that they can actually develop in a relatively realistic local environment, but you can spin up an equivalent version of that, later on in QA or in production, which may be scaled differently. You might have more servers. You might have, if you're doing it on Amazon, for instance, you might have a different flavor of an Amazon, you might have a different size, rather, of an Amazon VM, because you obviously, if you're running in production, it's slightly different. But basically, this ability to define an environment or a container that you then actually promote from dev through to production is very useful. Where do these things run into some challenges? Well, portable definition models can be a little bit restrictive. What do I mean by that? Well, if you have, there are some container models that allow you to say, I'm going to define this environment in such a way that it's not limited to, say, Amazon or OpenStack. I'm going to define an abstract VM that has so much memory and so much runtime processing power or whatever. And then I can decide whether I want to instantiate it on VMware or on OpenStack, and it'll take care of that for me. Obviously, that abstraction needs to cut away some things to be able to run in so many different types of environments. So these might be a little restrictive. And container models like Docker, of course, are also restrictive in the sense that they only allow you to define one machine. On the other hand, if you have a very flexible definition model that allows you to use any resource of a particular, say, cloud platform, that, of course, ties you very closely to that cloud platform, and that may not be something from a business risk perspective that you're happy with. If you're using one of these container models, so as I said, Docker is a good example here, you might also find that your application architecture has to be made to work with this setup. It's not necessarily easy to port an existing application into one of these definition languages. So good for greenfield, maybe not so good if you have to do this with existing applications. And then the other thing is, well, the reality of a lot of organizations is still, even if we're working together more in a kind of DevOps atmosphere, that certain groups will be responsible, will have responsibility for ensuring things like the security of the systems that end up running in production. And quite a few of these models are based on the idea that, yeah, well, we all trust each other, we'll define this thing. But then you can end up with a situation where a developer decides to configure the operating system in a way that makes it easy for the application, but that may be totally insecure. And you have to either catch that through review, or you'll end up with stuff running in production that is probably not what you want. So some of the more commercial products in this space, they have this kind of role-based control, if you like, where you say certain parts of my environment are locked down and are defined by, signed off by the operations people, but that's more the exception than the rule. So it's worth looking at your organizational landscape to see what's supported here. See, I need to speed up a little bit. Persistent data is always the elephant in the room. Most of these models are great, but yes, there's always a database somewhere. And how do you handle that? How do you make sure that the environment that you're spinning up actually has a suitable copy of the data loaded into whatever database it's going to connect to, or other external services that you consume? So in reality, application environments aren't fully self-contained. They still depend on some external resources, and these often fall outside the model that these cloud and container management tools give you. Creating the definitions, of course, is still, it's not a trivial drag and drop process. You have to sit there and pretty much script out a bunch of commands that make stuff happen. So yeah, I'm not going to go too much into the remarks because I've said a lot of this. Greenfield, you're probably in a much better place than if you have to take existing applications. You'll find you'll probably need to re-architect these. And certainly with the very fashionable models like Docker, the problem of actually getting that to run in a large scale, it's great to be able to spin up one process very easily on a Linux box, but doing the scaling, load balancing like 100 instances of those, taking them in and out, having one set where you have a certain set of features enabled and another set where you have a different set of features enabled, that's all left for you to solve. So there will be products doubts coming in this space, but at the moment, up to you to be creative and write your own dashboard, glue, whatever, to make this work. I mean, ultimately, this, I guess, is a little bit the difference between building your own platform as a service and using a hosted platform as a service, because ultimately that's where Docker came from. It was the container implementation behind a version of Heroku, .cloud. Right, system provisioning and configuration tools. So in these tools you can think of, Puppet, Chef, Salt, CF Engine, a bunch of others. Ansible, I guess, comes into this one a little bit. What do these tools do? Well, certainly I think from having seen them in practice in real life, what they're good at and what they're originally meant to do is allow you to define a state of a particular system, typically one box. And often that's in a sort of declarative manner where instead of giving an explicit list of commands that you want the tool to run, you're supposed to tell it, this is what I want. I want an Apache service, I want a directory over here with these permissions and this content. And what these tools do for you is they take that manifest or recipe or whatever it's called, that blueprint, and they turn the system into that desired state and they make sure it stays there. And of course, again, it's just another task running on a remote system. So these tools all provide a kind of underlying task execution framework which you can dig into to do what we said in category number 1, basically run arbitrary tasks on systems. So you can usually leverage that as well. What are they really good at? Well, they're excellent at maintaining large numbers of servers in some kind of known state. And because they make it much easier to bring a server into a known state, they also give you the option of saying if a server is broken, rather than investing a lot of time and effort trying to figure out what's wrong with it, you just kill it, start up a new one, and the tool will make sure it gets to the state it needs to be in, and it does that relatively quickly. So it also facilitates a more kind of throwaway model of target systems. Because they're designed to get systems into a certain state, they obviously provide a lot of out-of-the-box content here as well. And again, there's a bit of a difference to the task execution ones, where you basically have to script what you want to happen yourself. For you as well. And then because some of these tools have a focus of saying, machines might be longer lived, we're not going to throw them away immediately. We're going to make sure they stay in a known state. They can also show you in a sort of report what the difference is between the actual state of the machine and the blueprint that it should be in. And then they can go and stomp on the actual state and restore it to the blueprint and so on. What do we find that they're not so good at in practice? Again, once you start having sequences of actions that, a little bit needs to happen on machine number 1, and then something needs to happen on machine number 2, and then something on machine number 3, and then back to machine number 1, and they really have to happen in that sequence. We can't just run them all in parallel. That's when it starts to get a little bit difficult. It kind of interferes with some of the pull-based model that a lot of these tools have. And with a typical problem in application tier deployment, that's really the next point here. A lot of the out-of-the-box content pretty much stops at like getting a system ready. Actually getting an application on the system, there's not a whole bunch of out-of-the-box content here. So if you're talking about installing IIS web content or EAR files or WAR files or Apache configuration or making database changes, all this kind of stuff can of course be done because it's just another task. But you're going to end up leveraging these tools as a task execution framework and scripting the content for this yourself. And obviously from an application perspective, it's not just about actually running the commands in the right sequence. There's also a domain model attached to application delivery. You have natural questions like which version of an application is running in which environment. That's not really the same as what's the state of 150 systems out there. you can kind of try to extract that information out, but the domain model doesn't line up particularly neatly. So from the sort of application delivery perspective, it starts to get a little difficult to really see what you want to see here. And of course, you can architect your way out of this, but that's the general state that it's really behind. I must speed up here. Application integration. So this is the, well, often called continuous integration. I'm basically lumping build frameworks and continuous integration tools into one here. What do these tools do? Well, they take your source code and whatever other development artifacts you have, like configuration files and database changes and so on, and they turn them into a versioned package, something, version 3.5 of my app, and that's something that we could potentially release out to dev, test, QA, production, and give it to our customers. As part of creating this package, we have to run a whole bunch of tests and basic verification to make sure that it's a good package. And that's obviously what a continuous integration tool is primarily designed to do. Build your application, figure out whether it's good. And some of these tools also support the kind of pre-merge validation where before you actually make changes to your development, to your main branch in your source code repository, you can run these kind of tests ahead of time in order to figure out whether it's a good change to merge or not. And that's obviously, well, that helps you preserve your master branch in a kind of releasable state rather than making a change on the master branch, then discovering that you've broken stuff, and then having to clean it up before you back to a releasable state. What are these tools good at? Now, if you think Jenkins, TeamCity, Bamboo, TFS, whatever, yeah, they're great at doing pretty much anything that you can imagine doing with source code. All kinds of integrations with source code repositories, with unit testing tools, static analysis tools, code verification, blah, 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 the whole bunch. They can pretty much do any of that. They have the ability to run just not one task, but multiple tasks in some kind of sequence or in some kind of branching diagram to make it more efficient. Like if you're testing your mobile application against 100 different mobile platforms, then the last thing you want to do is do that one after the other. You can branch that out. And the ones that perform or that support this kind of validation, they also obviously help keep your main branch in a releasable state. What are they not so good at? Well, again, they're not so good coordinating sequence of commands across multiple machines. The typical model is that you have a job that needs to be run, and you have a pool of nodes or slaves or whatever they're called on which these jobs can be run. And once a job is dispatched to one of these nodes, it pretty much runs there and finishes there. And it's not easy to take a job that really consists of 2 steps over here, 3 steps over there. The only way to do that is to split that job up into n jobs, one per machine, and then make sure they get targeted to each machine, which starts to get very clunky because you end up having all these jobs, which really should be one job. These tools are obviously heavily used to build your package, and people have naturally looked to extend these tools to the next stages, which is typically spinning up environments, deploying your application out to the environments, and so on. And in a lot of cases, that's where the out-of-the-box content of these tools is much weaker. So you end up basically, again, using them as task execution frameworks. And some of them are not great at actually representing the sort of delivery process as a whole. Application deployment tools, well, they are supposed to precisely solve this problem. I have application version X, I need it running in environment Y, do it for me. And some of the tools, depends a bit on the tool, they can also help you solve the problem. Well, I don't have environment Y yet. I want to spin one up on demand. So go and talk to some other system and do this, or actually do it yourself. What are these tools good at? Well, they're good at obviously handling deployment-specific tasks, things like making sure you have an environment-independent package that somehow is configured correctly for this particular target environment, things like database credentials and anything that really needs to be specific to the environment. And of course, their main task is coordinating sequences of actions across multiple machines in some kind of easy and simple way, such as take a host out of the load balancer, stop the application server on machine number X, run a database update on machine Y, install a new application binary, and so on different machines in sequence. They provide a lot of content for precisely these kind of application tier tasks. So you shouldn't find yourself writing a deployment script for JBoss, for instance, or for Tomcat or IIS or whatever, because this is what the tools should deliver. They focus on that more than say, on the system configuration and installation level. So they're typically not that great at actually getting the systems up to the required state. And that's more the preserve of the kind of system configuration provisioning tools. They're also not necessarily, they typically expect that the package, that the validation you need to do on the package has already been done and that the package has been created. So they're not really a replacement for a continuous integration tool in general. And typically they also, since their focus is on getting application X running in environment Y, the fact that if you look at the entire end-to-end delivery process, you have multiple environments that you need to target, you have validation and testing steps between those, and approval meetings and whatever. Modeling that end-to-end workflow is not always something that they handle particularly well either. That leads us into the last one we want to discuss here, pipeline orchestration. What do these tools do? Well, that's precisely their job. They allow you to define the end-to-end delivery pipeline. And they, depending a little on the tool, they either expect a fully automated sequence or they allow you to define a kind of hybrid sequence where you have some automated tasks and some tasks are still manual, such as, you might be doing or spending manual effort in preparing your test environment today, but you may want to swap that out with an automated environment creation further down the line. What these tools are especially good at is providing you an overview of that end-to-end process, and hopefully all your stakeholders should be able to see which features are currently where in the pipeline on their way to production. Typically these are orchestrators, so they don't provide a lot of out-of-the-box content for actually doing stuff. You have to trigger other tools to do the work, a deployment tool, a continuous integration tool, a system provisioning tool, and so on. And some of the tools are strongly focused on fully automated pipelines. They're not necessarily that good at supporting a kind of team-based manual kind of approach. So looking at the time, I'm not going to spend too much time talking about this because I'd like to have an opportunity for some Q&A, but pretty much if I were to place these, I try to place them a little bit like this. Cloud and container management obviously at the bottom level, with ideas right now that maybe we can extend that all the way up if we just deliver a container. System provisioning and configuration tools used to set up your environments from dev all the way through to production and then maintain the production environment. Task execution could be expanded to do everything because ultimately everything is just a task, but in practice I think we really see them used most effectively for maintenance tasks, especially in the runtime production environment. Application integration deployment obviously spans the cycle from build to go live, and orchestration typically goes a little further than that, coordinating all these individual activities that are required to get your application out there. And they then provide the visibility towards your stakeholders, your teams, the business, to see what exactly is happening where. So which tools are right for me? Well, difficult one to do, obviously. Focus on the goals, not on the tools. So ask yourself, what are we actually trying to get out of this initiative? And then you can start to think about which tools we need. Identify that the biggest pain points that you have right now. Is setting up a new environment taking you 3 months and you would like it to take 10 minutes? Well, then you probably want to look at the cloud container management system provisioning tools. Do you find that your deployments are always manual or that your code is never in a releasable state? Then you might be more interested in continuous integration or application deployment tools. If you're looking at the delivery process, figure out which delivery model works for you. So can you expect your developers to deliver everything that needs to be running, a bit like a sort of virtual appliance? Or do you have an environment where there really is a split model, operations or some group defines the sort of platform with certain standards and security requirements and so on which applications get to run, and the developers just provide the applications and then you have to combine the two. And there is no one tool to rule them all. Certainly you can start out with one tool and you may find that the initial requirements that you have, you can use that tool pretty well, but it never stops there. At some point you will find that you're investing so much time and effort in extending that tool to basically cover things that other tools have a more natural sweet spot for, I think then the time is, it's a bit of a sunk cost fallacy problem. It's easy to think, oh well, it's just, everything's just another little script away. At that point, it's really important to take a step back and say, well, wait a minute, we're trying to use say a continuous integration to do system provisioning. That really isn't the smartest thing we should be doing. Can we get more bang for the buck, if you like, doing it that way? So just some contact information here. We'll hopefully have some time for Q&A. That's my email address if you have any questions, if you'd like to discuss anything more. Some links to our specific products and stack if you're interested in some of that. And with that, seeing as I'm a little late, I'd like to thank you and now move over to a bit of a Q&A for the remaining 5 or 10 minutes or so. So let me open up the questions window here. So yeah, please feel free to type questions in the window. And I would, if you have to go, yes, thanks very much for your time, but I would definitely recommend that you stay for this because often we find there are some very interesting discussions and questions that come up. Okay, so I see a question here. Many well-known DevOps tools are open source. Why should I consider commercial products which will eat into my budget? Now, that's a very good question. It depends a little where you are. If you are within the organization, if you have to jump through a lot of hoops to justify an expenditure and you have to write all kinds of proposals, definitely it's certainly easy to get started with an open source tool. Ultimately, what we find, some of the commercial tools are just more efficient. Some of them offer options that the open source ones don't. And most of the time, if you're going to go through the upheaval of changing a process, changing the way you do things, the cost associated with that and the effort is going to be much bigger than the license outlay for one specific tool. So in the grand scheme of things, the ROI should easily come out of, most tools here can pay for themselves quickly. Certainly that's what we see. I mean, we have a suite of commercial tools too, and we don't see that as a barrier to adoption. So it's certainly worth looking at what commercial tools are out there. And figure out, ultimately it's about figuring out what your ROI is. Another one here. You spoke about identifying DevOps goals. Can you give some examples of what you're seeing? I guess you mean by that, or that's supposed to mean what do we see out in our sort of customer base, the people we speak to. Well, I think that depends a little bit when whether we're speaking to the sort of CIO level, which is happening more and more now, or whether we're speaking to practitioners. I think a lot of practitioners are, well, they want to remove annoying and painful and frustrating tasks from their daily work environment, and they want to do cool things, and that is a motivating factor. Basically, they want to modernize. They want to feel that their operational or DevOps practice is as good as some of the market leaders, because that's the kind of environment you want to work in. So there it's a lot about emulating, it's about using smart tools, smart working practices, and being able to scale and be efficient. I think at the CIO level, well, we see that it's much easier to make a sort of big company-wide business case based on, we're going to deliver our products 6 weeks faster, and then we're going to make X thousand or million more quid. So a lot of the messaging at that level is really more around continuous delivery than it is about getting teams to work together better with smarter tools. But I think the important thing here is, it depends where you are, and you always ask yourself what are the things that you're currently suffering from. And I think one of the things I would emphasize here is there are still a lot of organizations whose DevOps goals do not really encompass anything along the lines of actually creating a more of a shared culture and a shared understanding. Because that's hard to do as well, but that's something that's very important. Simple questions like, is it possible for an operations person to put a feature on the development team's backlog to say, look, if you could add this particular logging, status page, whatever, the system would just become so much better? Or do the developers have early access to operations? Do they even have things like shared team meetings or shared outings or whatever? And that's how you create a common culture. Another one here from Alan. With extending Agile into DevOps, am I then not restricting my search in the personnel market to people with more and more skills and therefore commanding a high rate salary? Well, It's an excellent question, and one of the data points from the survey is that one of the biggest risks people see in implementing DevOps is that lack of knowledge or lack of training, lack of skills here. And it is fair to say, to be honest, this is also a little bit of some of the difference you see predominantly between the commercial and the open source tools. Quite a few of the open source tools here require, I'm not going to say they require lots of, they require some time to get your head around, some time to get into, and they are smart tools written for smart people. So that might be something where you want to look at a different tool set that focuses more on things like having a nice UI and things that are supposed to make them easier to use in the day-to-day environment. I guess, so it doesn't really answer the question fully. Yes, doing something smart is probably going to take people with some experience and skills. And right now, where a lot of organizations are still at the beginning of their journey here, those resources and skills are invariably scarce. So yes, that's a little bit of a problem. But if you look at the amount of kind of Scrum Masters that are out there now versus 4 or 5 years ago when Agile was still the cool thing to be and not the mainstream development methodology, then that's changed dramatically. If you look now at how many people in an average sort of release team have experience with, say, Jenkins, it's become a sort of standard piece of knowledge. So I certainly see there as well there's going to be a spread of knowledge. I think right now, things like DevOps Days, these conferences are practically free to attend. So if you're interested in getting your people trained up, there are still great opportunities to do this. And then, yeah, ultimately it's the question, if you want to be the early adopter, can you get more benefit out of it? And this goes back to the goals. Then you're going to have to invest in terms of training, hiring the right people, and so on to make this work. If you feel that that equation doesn't work out for you, then yeah, maybe waiting a little bit until your investment needs go down. So I've already run 5 minutes over. Let me take one more question. I will get back to any other questions afterwards. And of course, as I said, please feel free to email me and continue any discussion with me or with us about any of these topics in more detail. You mentioned finding the biggest, I think it's a good one. You mentioned finding the biggest pain points, the first step. Have any thoughts or ideas on how to go about this? Yeah, it's always easier said than done, that, I guess. I think some of the things here that really help, you have to, first of all, have a feeling that things can be improved within your organization. I think one of the biggest challenges that I've seen here is not necessarily a technical thing or a process thing, it's more of an attitude thing where people feel this is just the way it is. It's a sort of, it's always been this way. It's from the dawn of time, this is the way we've always done stuff. No, it's not great, but it's like the rain. What are you going to do about it? That is no longer true. There are plentiful use cases out there, not just of companies like Google, where you could realistically say, yeah, but we're not like Google. That's true. But there are companies across all sectors of industry, banks, telecoms, well, more financial, retail, you name it, from bricks and mortar companies to online retailers. They've adopted these practices and they've proven that you can really get benefit out of this, even if you're not the hippest tech startup on the planet. So that should hopefully increase the feeling that, yes, we can change and we can do things better. But that feeling does have to be there. And that also means if you want to, especially if you want to get money to do things or change processes, you need executive level, some kind of buy-in, at least from your manager, to get some time to look at this. So, you can try to do a little bit skunk works, but certainly make sure you have support for this. There should be enough justification to spend some time looking at this. And then, as a practical first step, do something like a value stream map. Whether it's for a single process like getting an environment up and running, typically it helps. If you look at the end-to-end service delivery process, if you say from the moment where we have an idea to the moment when it's running with our customers, and do we know what our customers think about it, how does that process actually work? How long does it take? Where is the idle time? So value stream mapping is a lean technique. You basically draw out the process and figure out where you have gaps, waste, and idle time. And then you can hopefully start to figure out, well, where's the pain? What's hurting us here? But also, what's the low-hanging fruit? So some things might be hurt a lot, but they might be very difficult or expensive to change. Some things might be very simple, like, I don't know, we typically wait over half an hour to get an integration test build run simply because we don't have enough build slaves in our continuous integration machine. That should be something that's relatively easy to save, and if you multiply that time saving across a couple of weeks or months, then you're really having having a good benefit for a little investment and effort here. So yes, value stream mapping, but as a practical point, but especially make sure that there's an openness to change and an agreement that it's not about blame, it's about doing things better, and make sure that the managers and the people who are ultimately going to benefit from it, namely the business, are behind this. So thank you very much, especially those of you who stayed on over time. Hope you have a remainder of a good lunch break and certainly a remainder of a good day. Please feel free to get in touch with me for any more questions, and thank you very much.
Thank you very much, Andrew. This is Alec again from Unicom. Just to wrap things up and say thank you on behalf of Unicom. And to let you also that if you'd like to meet XebiaLabs, they'll be coming to the DevOps Summit in London in June. And there's also another DevOps Summit which is taking place on 13th of May in Amsterdam. It's available at devopssummit.com. And just a reminder also that the webinar recording will be available. What we're going to do is send everybody who attended a link afterwards. So again, thank you everybody for your time. Thank you. Goodbye.